Let's go with a little bit more synthetic division. Why synthetic? Because it's a shortcut, and we always try that if we can, and we can. We are dividing by a linear term whose leading coefficient is a 1. Now, well, I don't want to get ahead of myself. That's another video. Anyway, linear term, leading coefficient is a 1, so let's set it up that way. So what color do you want? Nope, not that one. It won't show up. Nope, not that one. It won't show up either. How about this one instead? Here we go. Let's make a little half box. And in that half box is the opposite of -6, so +6. So again, this is that situation where I said, oh, look, if that's a factor, it may or may not be, but if that was a factor, what would the root be? The root would be +6. And then we're going to take these coefficients in order. Don't change their signs. 1, don't forget you understood 1, -2, -14, and 24. And something that happened in my head, and hopefully it happened in yours too, and this is going to come in handy in the next problem. Were you missing any terms? As you counted your exponents down, 3, 2, 1, constant, no, you weren't missing any terms. So there was no need for a 0 to go in as a placeholder. All right, this is going to be my remainder. Remainder, you don't have to write the word remainder every time, but I want to. There we go. And we'll switch colors again. Yeah, purple, you called it. And we're going to bring down your 1. Okay, before we go any further, that means your final answer will start with 1x squared. It would be cubed, but you just divided an x out of it, okay? So just jumping ahead here. All right, 1. 6 times 1 is 6. -2 plus 6 is 4. 6 times 4 is 24. -14 plus 24 is 10. 6 times 10 is 60. 24 plus 60 is 84. Okay, we do have a remainder in this case. We'll deal with it in a second. So my final answer in black is 1x squared. It was cubed, but we divided by linear, plus 4x plus 10. Okay, now we have a remainder to deal with. And when we had done long division, and I still have those notes, when we had done long division, where are they? And we had a remainder, there we go. We would put that remainder over whatever we were dividing by in the first place. And that happened there. It did not happen on these, and the other ones were done on paper, so I don't have that. But what I do have is a remainder of, I lost my place. Okay, there I am. A remainder of 84, and all that rambling and scrolling was basically me saying we're going to divide by whatever we were dividing by in the first place, whatever our divisor was. So you might say 84 over 6. No, not 84 over 6, 84 over x minus 6. And again, that was what all that random scrolling was for. Here, let's try this again. That is whatever you were dividing by in the first place. That's your denominator on your remainder, okay? So that's what the remainder is going to be represented as. So it's plus 84 over x minus 6. If it was a 0, we wouldn't have to put it. Okay, let's tackle the next problem, and the next one's going to be kind of interesting. Scroll up, and it says, it's represented differently as well, x to the 5th minus 32 over x minus 2. This one's fun. This one's a lot of fun. I want to write this one out a little bit differently. Notice that the denominator, what you're dividing by, is linear, leading coefficient of 1. Handy, synthetic division. It's going to come in really handy. But before I go any further, let's just go ahead and fill in the things that are missing. And the things that are missing is a lot. I have x to the 5th. I don't have x to the 4th. I don't have x to the 3rd. I don't have x squared. I don't have x. I do have a constant. So start at your highest exponent and then fill in any gaps that you have with the 0, which we have done. All right, we'll switch colors to, yeah, we'll use red. A little alarming, but we'll do it. Okay, when we divide, we're going to take our divisor and change the sign of that constant term. So if x minus 2 equaled 0, x would equal positive 2. All right, so we have positive 2. And then we're going to have 1 x to the 5th, there's your 1 right there, 0, 0, 0, 0, negative 32. 0, 0, 0, 0, negative 32. Here's your remainder right there. Wonder what that remainder is going to be. I'm not telling. I almost blurted it out. All right, green. Why not? 1. Bring it down. Let's go faster. Multiply. Put it there. Add. 0 plus 2. Multiply 2 times 2. 4. Put it there. Add. Multiply 2 times 4 is 8. Put it in the next column. Add. Multiply 16. Put it there. Add. These go fast after a while. Multiply. Put it there. Add. Remainder of 0. This is neat. I love it. There's a structure to this one. It's very similar to the sum of cubes or difference of cubes, but this is to the 5th power. The structure holds as you expand and get bigger powers. Anyway, that was free. You didn't need to know that. We'll write the answer in blue. The original problem was x to the 5th, but we got divided by a linear term. So therefore, it's going to be x to the 4th. So 1 x to the 4th, 2x cubed, 4x squared, 8x. Notice my exponents are counting down. 4, 3, 2, 1, and then 0, technically. 0 exponent, which means it was useless, so don't write it. You can if you want to, but it's useless. And then remainder of 0.